Hi, I'm Pat Kelly. Okay, and this problem is one of a lot of problems that we'll end up doing where they give us a series and they ask us to determine if it's convergent or divergent, and you get to use any test you want. But that's the challenge, trying to decide which test is going to work out real well for you. Okay, so for me, my choice here in terms of which test is I'd have to look at it for a little bit and think. And sometimes you even do a little bit of work with paper and pencil and maybe erase and go back. But my thought is when we have these powers that have n in them, a ratio test really works well a lot of times. So I'm going to try the ratio test for this particular problem. Now with the ratio test, what we're checking is the limit as n goes to infinity of the a sub n plus 1 term over the nth term as an absolute value. Now we'll put in the particulars for us for this problem. We have the limit still, n goes to infinity still. And now the n plus first term is just taking this expression, putting an n plus 1 in wherever there's an n. But even as I do that, you can see I'm pausing because we do have the absolute values, which helps us whenever we have like a negative 1. I don't need to worry about that at all. So I'm just going to go right to the 3 raised to the n plus 1 minus 2, so n minus 1, divided by 2 raised to the n plus 1. And that's just my numerator here, down in the denominator. A sub n is just exactly that original expression, but again without the minus 1. So I'll have 3 raised to the n minus 2 divided by 2 raised to the n. And let's just clean that up a little bit. Limit still, n goes to infinity still. Just so that the algebra is real clear, I'm going to take the time to rewrite this even as like an invert and multiply step. So 3 raised to the n minus 1 over 2 raised to the n plus 1 multiply, flip, we'll get 2 raised to the n over 3 raised to the n minus 2. Okay, the algebra is looking pretty good to me now then, because I'm going to simplify in the next step. And the algebra that I was talking about is, okay, well, here in the numerator we have 3 raised to the n minus 1. Downstairs we have 3 raised to the n minus 2. That gives us one more factor of 3 in the numerator than the denominator. So it's going to simplify to just 3 up top. Something similar is happening here with the 2's, 2 to the n up top, 2 to the n plus 1 in the bottom, so one more factor of 2 downstairs. That's how that simplifies, and that really simplifies the limit. Our answer is 3/2. Good work. But that's the answer. It's good work for the limit. Now back to the context of this being an infinite series. This comes down to making sure you know how to interpret your work within any one of these tests. So we are using the ratio test. Your interpretation of the work involved in the ratio test is whatever answer you get for your limit, you're now really kind of questioning how does that compare to 1? This is greater than 1. You want to know, is it less than 1, greater than 1, or maybe possibly equal to 1? We're greater than 1. That gives me my answer now. Get down to writing my answer. Because that limit that we looked at of a sub n plus 1 over a sub n, absolute values, is, what were we, greater than 1? My interpretation is that the given series, do you know, diverges. When we're greater than 1 with this test, we get divergence. Okay. If we're less than 1, it would converge. If it equaled 1, that's the yucky one. That means it's inconclusive and we would use a different test. Okay, so my final answer for this is that the given series diverges. And let me also back up and remind you, this problem started with us making a choice. You might make a different choice and you can still get the same answer. If your choice of test works, you will get the same answer. But the catch is sometimes you make a choice, try a different test, and you don't get anywhere. Don't get frustrated, just back up and try something else. In this case, the ratio test worked for us. Okay, thanks, and I hope that helped.